Hey guys, welcome to the first of distance learning videos. This is for lesson 8-1, adding and subtracting polynomials. Today's date is 3/31/2020. So we're going to do a couple of videos a day, off and on, and ones that we feel like we should do separate, we do separate, and so on and so forth. That will happen for a little while, and I'm not sure how many videos we'll do per week, really. We'll have to see how things go. But I just need to let you know that my screen is written more in landscape than it is in portrait, whereas your paper and your spirals are portrait. So what's going to happen is I'm probably going to have to use 2 pages to represent the notes portion, or two screens, excuse me, for the notes portion, and then the third screen will be technically the second page. So I will not be on the second page until you see me write the title for the lesson again, okay? Now, because we're starting in a new chapter, we're going to be focusing on this new idea of polynomials. So let me underline that guy for you. And so we're going to start with some definitions because we always begin with vocabulary when we start a new lesson. So what on earth do I actually mean by a polynomial? So a polynomial is a monomial or sum of monomials. And another word we use for monomials is the word terms. Okay, these are things that are separated by pluses and minuses. They're not things separated by multiplication or division. Okay, so and we talked about this in an earlier chapter. Now there are 2 other types of polynomials that are important. So important they have their own names. So the first one is a binomial. So the term in the front, the prefix, is basically telling you how many terms it is. So a binomial, like a bicycle, is 2 terms, okay? And they are we can say sum of 2 monomials, but there can be subtraction because remember, we can rewrite any subtraction problem into an addition problem by adding the opposite. Okay, and then the other one is the trinomial. So tri, just like tricycle or triennial, make sure nomial, yep. That means 3. So it's the sum of 3 monomials. Okay, so you will be using those words binomial and trinomial throughout this lesson. Now, we are going to also talk about something that's a little strange, and my reasoning of saying strange is that it's not something we deal with a whole lot at our level, but it is something for you to, oops, wrote with the wrong pen, sorry. It is important for you to understand this as well. And this is called the degree of a monomial, and then we also have one of a polynomial. So let's start with what do I mean by the degree of a monomial. So remember, monomial just means one term. So there could be multiplication happening to it, could be divided by a number, but there's only variables in the numerator, right? So it's the sum of the exponents. And what you're hearing clicking is my Apple Pen making contact with my screen. Of all, I'm going to underline that guy. Oh, actually, let's box them. All of the, and here, waiting for it, variables. So the coefficients mean nothing to us in this, just the variables. So the sum of the exponents of all of the variables for a monomial. Oops, sorry. I once asked my 6th graders, monomials, if the pen made, bothered them. I had kids say, no, it's actually soothing. I'm like, okay. So once we understand what the degree of a monomial is, then we need to understand what the degree of a polynomial is. So degree of a polynomial. So the degree of a polynomial is the greatest degree of any term, which is another way of saying monomial, in the polynomial. So just like in class, you are copying everything I'm writing and you're listening to everything I say, okay? Okay, so let me give you a couple of examples and we'll kind of, because we're going to have to figure out the degree of each monomial, and then based on whichever one was highest is going to be the degree of the polynomial, okay? So let's deal with negative 3y squared minus 2y plus 4y minus 1. Okay, so the first thing I'm going to do is I am going to simplify when I can. So when I simplify, I get negative 3y squared plus 2y, because these two signs are different, so I'm going to subtract bigger numbers positive, so I get a positive 2y left over minus 1. And this gives me a trinomial. Sorry. Okay. So let's go ahead and look at the degrees, and we'll look at this version that's been simplified. So let's see, y squared, we only have one variable, so it has a degree of 2. There's none on, we have none for the the coefficient, and we have 2 on the y, so that's a degree of 2. We have none on the coefficient, and we have 1 on the y. Remember, if you don't see it, it's still there, so that's a degree of 1. And remember, we're only looking at the variables for the degrees. So we would say that the degree of the polynomial is 2, equals 2, okay, because that's the highest of all of those numbers. All right, so next thing I want to talk about is something called standard form. We've talked about this, and I've said standard form comes, we use that same term, but it means different things in different situations. So standard form for a polynomial. Whoop. And it says a variable is written in decreasing or descending, oops, that's the word that's more commonly used, order. Oh, degree order, sorry. Actually, let's put it here. Degree order. Okay, and the constant is at the end. So I'm going to go ahead and take this guy, descending degree order with the constant at the end. Now, you may have seen this on Alex. I don't know if you guys have gotten there. Just to let you know that it is possible for there to be more than one variable, in a polynomial, and so people get a little confused how to do decreasing when I've got an x with decreasing exponents and I have a y with decreasing exponents. So usually we go alphabetically, and whoever comes first in the alphabet, we're going to decrease him, and what that's going to do is put the second variable usually in a ascending order. So there's usually, or increasing order, so there's the degree. So there are always weird exceptions, but we'll be playing with this one. Now, I think I have room for one more definition here. So let's go and talk about him. And that's going to be, what do we call a leading coefficient? So remember, always our first sets of notes for chapters seem to have a ton of definitions. That was weird. Leading coefficient. Okay, so the leading coefficient is the coefficient of the first term in a polynomial written in descending degree order. So I'm not going to use that word decreasing, just making sure you understood what it meant. So let's do an example of that. So let's say we've got 4x cubed minus 5x squared plus 2x plus 7. So first thing I want to do is make sure it's in descending degree order. So the exponent goes 3, 2, 1, none. Okay, that's perfect. So then I'm going to look at what the degrees are for each one of them. So this one is a 3, this one is a 2, this one is a 1, and this one is a 0. So I'm looking for the leading coefficient is the one that matches the largest degree, the largest exponent. So that would mean that the leading coefficient goes with the x cubed, which has the highest degree. So the leading coefficient would be the coefficient 4. Okay. Now, this set of notes is still going to continue. This is still the same page, but I've run out of room on my screen because of the way the page is set up. And we're going to go ahead and talk about how do I add or subtract polynomials. Now, by the way, it's kind of boring to write these titles, so you can always kind of write it, pause it. That way you're not wasting too much time doing it with me if you want, or you can do it with me. It's up to you. So to add or subtract polynomials. So I'm going to give you two strategies. Strategy 1, method 1, is we're going to do it horizontally. Okay, and normally when we do any kind of operation, we tend to do it vertically, which that's the method that I prefer myself. But but again, this is up to you to decide. So with method 1, we're going to, we have two polynomials with adding, okay? So if it's an adding problem, we're going to use the commutative property. Remember, that's the guide that says changing the order of what we're going to add isn't going to change our answer. We're going to use the commutative property of addition to rearrange like terms together and then we're going to use the distributive property, and then we're going to combine like terms. And if you remember, that's going to be the coefficients only. Oops, Yeah, I did spell that right. Okay. Now, if it is subtracting, you have to watch out for signs. That's going to be a big problem here. So if we're going to subtract, you have to watch your signs, and you will distribute the negative, which is our subtraction sign. Now, it could be, no, I don't know if I've seen it. No, probably not. So distribute the negative, that's the subtraction sign. Because remember, we can add the opposite, so it's adding -1 times the quantity to each term that follows it, right? So that's going to be each term in the second polynomial. Okay, so that's the one that you have to watch out for. So we're changing all, distribute the negative to each term in the second polynomial, and then it becomes an addition problem. Then add like terms. Now again, adding sometimes means you subtract because the like terms have opposite signs. So that's one strategy. The strategy I like is the, oh, sorry, my pen got moved around, so now I do things incorrectly sometimes. So method 2 is vertically. So on this one again gets a little strange. So you got to remember, you got to watch signs. So I'm going to just throw that back in here. Okay, so watch signs. And we're going to, so the second polynomial, if it's a subtraction problem, you're going to distribute the negative. But then what you're going to do is line things up vertically. So this is how we're going to talk about that one. So we're going to line up vertically, so one underneath the other, the like terms in columns. Then combine like terms. Okay, now the other thing to be forewarned about with this method is that make sure that you start both of your polynomials already in standard form. So write each polynomial in standard form first. Okay, so now I'm ready to go over to the second page of my notes. And remember, you guys can pause it anytime. If I'm talking too fast, you can slow it down. I know some kids sped it up so they can get through it faster, but it's up to you, okay? But don't skip anything. All right, I'm going to go to the next page. I'm going to go ahead and title it again with lesson 8-1, and we have adding and subtracting polynomials. And so now we're going to get to the actual practice. And again, we're at 3:31, 2020. Okay. So the directions, we're going to break it down into adding and then subtracting. So the directions for adding would be find the sum. So I'm going to solve these problems two ways. I'm going to solve one with the horizontal method and one with the vertical method, and that way you can kind of make your own decision. So we've got 2x squared plus 5x plus 7. So sometimes what your book will do is it will put parentheses around here's where this guy begins, and this is where this guy ends. Here's the second one, so on and so forth. Okay, now, because this is plus, nothing's going to happen to the second polynomial other than we're going to drop off the parentheses. So what we can do is link up the like terms. So for example, 2x squared matches with negative 4x squared. All right, so I'm going to put them together. So I get 2x squared minus 4x squared. And notice I'm going with the first polynomial that was already written in standard form. I don't have to change the second one. Next, I have 5x and I have 6x. So they are going to get written together. Now, this is an addition problem. I'm adding the answers to each of these. Now, the sign may end up being negative, right? Because whatever the coefficient comes out to be. So I have 5x plus 6x. And then I have plus, and then I'm going to take my constants, and I'm going to add them up. So I get 7 plus 3. So this is pretty much a brain step, right? This is what I'm doing inside my brain. So when I finish, I'm going to end up with negative 2x squared, let's see, plus 11x plus 10. And there's my solution. Okay? So let's do the next one. We've got 3y plus y cubed minus 5. And we're going to add to that 4y squared minus 4y plus 2y cubed plus 8. Okay, so notice both of them are messed up. Also notice that we've got a polynomial that's a trinomial, the first one, and the second one we just call, anything above 3 terms we just call a polynomial. So a little hint, think about when we were adding when we were younger, we always put the longer number on top and the shorter one on the bottom, just like multiplication does the same thing. So that's what I'm going to do. But I do notice I've got a bit of an issue when it comes to, the second one, and that's my polynomial is not in standard form. So I am going to rewrite this in standard form, and I'm going to put it on the top. So in standard form, let's see, I get 3 comes first, so I get 2y cubed, then comes a y squared, so plus 4y squared, and then I have just minus 4y, and then I have a plus 8. So the other polynomial, what I'm going to do with him is match the partner. Now I don't have to rearrange him because I know that 3y is going to go with the minus 4y. So I go plus 3y. And then I know that the y cubed is going to pair up with a 2y cubed. So we have a positive y cubed. And then I know, let's see, we'll do this color. Negative 5 is going to pair up with the 8. Okay? And then I just go ahead and I add them. So it's just an adding problem, right? So 2, and remember, if I don't see the coefficient, it's always 1. So 2 plus 1 gives me 3y cubed. I don't have any y squared, so he just comes down. Negative 4y plus 3, the signs are different, bigger number's negative, so I'm going to get a negative y. I'm not going to write a 1. And then 8 take away 5 is positive 3. And that's the answer there. Okay, on this side, we're going to find the difference. Now, on your page, because I have this wide screen, on your page, what you guys might be doing is writing this underneath those 2 examples. Okay, so it's up to you to decide how to write it. So I've got, let's see, 3 minus 2x plus 2x squared, and I'm going to subtract from it 4x minus 5 plus 3y squared. Okay, so the first thing we had talked about is we got to distribute that negative. That's the first thing. Next thing I'm going to do is as I do with the first guy, or the second guy, I am also going to at the same time take the first polynomial and rewrite him in descending degree order. So that means the largest exponent is a 2, followed by an exponent of a 1, followed by no exponent. Now, what's happening to the other guy is I'm going to distribute. That is really a negative 1, because really what I'm doing is adding and then the opposite. So it's negative 1 times, okay? So I'm going to now have a plus here, and then whatever signs I get individually, okay? So I get, oh, I don't want that to do that. I wanted it to be negative. All right, let me change this. I don't know why I wrote a plus there. I got excited. Okay, so plus a negative 1. So negative 1 times 4x is negative 4x. Negative 1 times a negative 5 is a positive 5. Negative 1 times a positive 3x is a negative 3, or 3x squared, is a negative 3x squared. All right, so now this is when I would use my commutative property. I'm going to show you how I would do it. Instead of that brain step, I'm just going to kind of do it in my head. So I'm going to go squared to squared. So I have 2x squared minus 3x squared. That's negative x squared. And then I've got, let's see, a negative 2x and a negative 4x. Ooh, the signs are the same, so I'm going to add up, and I get negative 6x. And then I've got a 3 and a 5. So that's going to add up to 8. So that's my answer right there. Very colorful, but my answer nonetheless. Negative x squared minus 6x plus 8. And so then the last example, this is the trickiest one of all, okay, because of the way that it's written. And this is where more people make mistakes than any other place. Because what they write is something that looks like this. And they've already kind of written it vertically, but right now it doesn't really make sense because like things aren't lined up with each other. And so it looks like 7p plus 4p cubed minus 8, and then minus 3p squared plus 2 minus 9p. But what it really is telling you is that you're subtracting that entire polynomial. So we are going to need to distribute that negative to everything on the bottom, okay? The other thing is our top polynomial is not written in descending degree order. The other thing, notice that we have a degree of 1, a degree of 3, and a degree of 0, but there's nothing for a degree of 2. So I'm actually going to make a provision for him. That's how I do it. I give him 0 as a coefficient, which means when I multiply, I get 0 for that term. And then I have 7p, and then I have minus 8. Now this guy, I'm going to do two things simultaneously. First, I'm going to distribute the negative and then place it. So negative times 3p squared is negative 3p squared. A negative times a 2 is a negative 2. A negative times a negative 9p is a positive 9p. Now I'm going to draw my line, and now it's an adding problem. So I have 4p cubed minus 3p squared. Signs are the same, I add, I get 16p. And signs are the same, and I add, and I get negative 10. So there you go, guys. Choice is yours. Whatever strategy works best for you. All right, this is like a very, very long video. They will not be this long all the time. All right, thanks, guys. We'll see you soon with the second video. Bye-bye now.